Hi everyone. This lesson is a little bit of a history lesson in why logarithms were invented. So with logarithms have been around for many centuries before electronic calculators, and the usefulness of logarithms is that we can do difficult problems like this where we need to multiply much more easily. So let's take a look at what we would do. I have some logarithm tables here. Now our first number is 214.6. So I go to my table of common logarithms. Now there's no decimal places and so forth, but these numbers down the side here, that's 1.0, 1.1. Right? Now I'm not going to get a number as high as 214. I'm only going to go from 1.0 down to 9.9. So I need to use multiples. I'll need to think of this as 2.146 multiplied by 100. Now let's go and look at 2.146 in my log table. So 2.1 is here. Just let me highlight 2.1. Now if I want to go 2.14, I need to come across to this column. So this entry here is, got the wrong row, helps if I do it correctly, 2.14, that's this number here, the 3304, but the number I'm dealing with is 2.146. Now to save a little bit of space in the printing of the table, we come across here to the number 6, the differences of 6. See that difference is 1, 2. So we have to have this 3304 and add 1, 2. It would actually be 3316, and that's our logarithm of the number. Now what is a logarithm? A common logarithm is a power on 10. Did I say that was 3316? It was, wasn't it? Yes. So by the time I have 2.14 and the extra 6, it's 3316. So it's 0.10 to the power of 0.3316. And of course, 100 is 10 squared. Now, when you practiced at doing these things, you wouldn't have written down that second line. That second line would have been something you kept inside your head, because you literally could have looked up the 2.146, and you would have noted the fact that the number you're dealing with is 100 times larger, and you would have just automatically put a 2 here at the front. That's what we would have, once you practiced at using logarithm tables, you would have gone straight to that, 2.10 to the power 2.3316. Now let's look for 3.921 in our logarithm table. 3.9 is down here. The column for 2, the second column, so 3.92, that's that number, and it was 3.921, so we have to add on that first little difference there. So my logarithm is 5934. 5934. And there's no powers, it is literally 3 point, it's not times 10 or 100. So it is the 10 to the power 0.5934. Now once you get the hang of these tables, you look them up really quickly. So instead of multiplying two 4-digit numbers, I just need to add these two numbers. Now what happens when I have 4 plus 6, that's 10, carry a 1. 3 plus 1 is 4, plus that one there is 5. 9 plus 3 is 12, carry the 1. 1 and 5 are 6, 6 plus 3 is 9, and there's still a 2 at the front. And again, I would think of this as 10 to the power 0.9250 multiplied by 10 squared, multiplied by 100. But the difficulty then is, I suppose, where do I find the 10 to the power 0.9250 without a calculator? And that's where we have an anti-logarithm table. Magnificent. Now this was 0.9250. So notice the decimal points are included in this table. So I've got to go find 0.92. Where's 0.92? There's 0.92. And it was 50. So the 5 is that column there. So there's the... Now the extra digit was a 0, so there was nothing else to adjust. My answer is... Now these ones again would have... they would have had a decimal between the first two digits. So it would be 8.414 would be the answer, but they didn't print the decimals to save space. So 8.414, where did my working go? Oh, there we go. This is 8.414 from the anti-log table multiplied by 100. Now, of course, when you're accomplished at doing this, multiplying by 100 just means moving the decimal point 2 places to there. And I've taken out half of the 4. And, of course, when you're really accomplished at doing this, we would have just had the 2 there. We would have looked up the anti-log of 0.9250, and then we would have made it 100 times larger. So this is how we do, how we use logarithm tables in the past, before the days of electronic calculators, to multiply large numbers together. Now this table is 4 significant digits, 4 figures of accuracy. So this would be a reasonably good approximation to this result. Of course, that's a lot quicker and easier to add 2 numbers than to multiply those using pen and paper. You can check the result on your calculator if you want. If you did multiply it out the long way, and if you really want me to, I will. Oh, all right then. I can hear you saying you want to see me do this. So it's 214.6 multiplied by 3.921. We better leave ourselves a bit of extra space here, because I will need some place for carryover digits, won't I? Let's pop this down over here so I've got plenty of room to do this work. So doing this the long way. 1 times 6 is 6. 1 times 4 is 4. 1 times 1 is 1. 1 times 2 is 2. Put a placeholder. 2 6s are 12. Carry the 1. 2 4s are 8 and 1 is 9. 2 1s are 2. 2 2s are 4. Put 2 placeholders. Now 9 times 6 is 54. Carry the 5. 9 times 4 is 36. 36 and is 41. Carry the 4. 9 1s are 9 plus 4 is 13. Carry the 1. 2 9s are 18 plus 1 is 19. Put 3 placeholders this time. 3 6s are 18. Carry that. Now I might just rub out those little carry digits that I had there, because they're going to confuse me if I don't. So let's do that first bit again. 3 6s are 18. I wrote down the 8. Carry the 1. 3 4s are 12 plus 1 is 13. Carry the 1. 3 1s are 3 plus 1 is 4. And finally 3 2s are 6. Now we have to add all of these. 6 plus all of those zeros. 4 plus 2 is 6. 1 plus 9 is 10, plus 4 is 14. Carry the 1. 1 and 2 are 3, and 2 are 5, and 1 is 6, and 8 is 14. Carry the 1. 1 and 4 are 5, and 3 are 8, and 3 are 11. Carry the, that's 11. Carry the 1. 1 and 9 are 10, plus 4 is 14. Carry the 1. 2 and 6 are 8. Now, how many figures did I have beyond the decimal? I had 1, 2, 3, 4 of them. So I will need to move 1, 2, 3, there we are. I have produced the answer by multiplication of 841.4466, which of course is the correct answer. But how much more difficult was it? And with my logarithm tables, in one simple process of adding 2 numbers, then looking up the anti-log table, I get an answer which is accurate to 4 significant figures, which for most purposes is going to be the degree of accuracy that you will ever need. That's why logarithms were invented. So we could quickly and much more accurately perform difficult multiplications. Thanks for watching.